and from SHM this question is taken, and we will be explaining in details what is the question, though I already mentioned into the description of my live session. You can go through that, and let me read it out. So here it's given that a body is supported by light a spiral spring. So let's say if this is the spring, okay, and the body is supported over here, and let's say this is the body, and the mass of the body is m, and this is suspended through the spring like this, right? This is the mass, and the spring is suspended from this roof, okay. So it's given that the body is supported by light spiral spring. This is the spring, this is the mass, and causes a stretch of 1.5 cm, right? So here it's given that the stretch can be calculated or given as 1.5 cm. So this can be calculated and converted into meter, right? So this can be written as 1.5 cm, which is equal to 1.5 by 100 meter. So this will give you 0.015 meter. So this is the value of stretch. Stretch, that means this elongation from this point. So this point there is some extension due to the weight of this mass, okay, and this is called the stretch, right? This extra elongation into the spring, and that is happened due to the suspended weight, right? So into the question is given that a body is supported by light spiral spring and causes a stretch of 1.5 cm, which is equal to 0.015 meter in the string, right? Now if the mass is now set in vertical oscillations of a small amplitude, what is the periodic time of the oscillation? So this body is, due to the weight, it's exhibiting SHM, okay. So this simple harmonic motion, that means this body is coming down, then going up, then down, then up. So these vibrations are happening over here, and these vibrations are due to the spring, and let's say the spring constant now, okay. We know by the formula of when a body is suspended through a spring, then force can be written as F equal to minus kx, right, where k is the spring constant, right, where k is the spring constant. This is the spring constant, and this is elongation x, okay. If this is spring is stretched by x, then the restoring force will be equal to minus kx. This is the formula, okay. So here the spring constant, what is the unit of spring constant? It's Newton per meter, right? So let us find it out. So if the weight of this mass is mg acting downward, this mg is acting downward, then this force, restoring force, will be acting where? Into the spring in upward direction, right? Now when you equate it, what we will get? This mg, let me write it out. This mg, this weight of this mass, is equal to the restoring force kx. Let us put the magnitude only, okay, because this minus is due to the opposite direction, because this weight is pulled up in the upward direction, that's why it's mentioned minus, right? Now what is the value of F? We can calculate, right? If the mass is displaced by x, suppose from this is given, this x is additional to this 1.5, right? So let us assume the extra extension is x after 1.5. So extension total extension in the string will be how much? This will be 0.015 meter, which is already given, already stressed, plus x, right? So this is the total extension. So in place of this x, this value will come, right? For the new condition, okay, I given to you. That means it's mentioned that if the mass is now set in vertical oscillations of a small amplitude, what is the periodic time of oscillation, right? Now we can write m into g is equal to k times x. What is the value of x? X is 0.015 plus x, because this is the new extension. So total value will be 0.015 plus x, right? Now the total force, this mg was equal to, k times this new extended, okay? Now the difference of this will give you the force. So this can be equated, this is the new one and earlier was kx, right? So the net force, the restoring force, is opposite to the displacement, right? So that is F equal to minus kx, which you have already mentioned. Now the time period, what is the time period of oscillation that we need to calculate, right? So from here just write the value of, we know the time period of oscillation in a simple harmonic motion can be given as 2 pi root under m by k, right? Now the m is already, m will be cancelled out when we will put up the value of k, right? Now just put up the value over here. Since kx equal to mg, here we have already put it. So from here we can write the value of k as mg by x, isn't it? Mg by x. So what we will do, just simply put up the values. So this will give you 2 pi root over of m by k, and in place of k, it's mg by x, right? So it will be mg by the extension. What is the extension? 0.015, right? So here m and m will be cancelled out and we are left with 2 pi root over of 0.015 will be going upward, so 0.015 by g, the value of g is 9.81, right? So this is the time period of oscillation, and when you solve it you will get it, you will get the answer, because it's a simple arithmetic calculation. Okay, if you want me to, let me do. So t equal to 2 pi root over of 15 by 1000 into 100, this 100 from 9.81 divided by 981, right? So this will give you 100 and 100, 20 will be cancelled, and this 3 5 times 3 39 326 37 327. So this will give you pi root over of and 5 2 times 10. So it will be 1 by root over of 2 7 14 4 654, 1 by root under 654. So this is the time period of oscillation, this much of second, students. Okay, you can easily solve it, you get the answer. Okay, so in this way we can solve such questions, students. For any doubt you can put up into the comment box, we'll get back. Okay, thank you so much for watching. Take care. Bye bye. Happy learning.